All right, hey, good morning. I'm not going to make y'all say howdy again. I think we got that out of our system already. So I'm Rob Fox, and I'm going to talk to you all about the concept of lean sustainability. Okay, so the first principle, as we go through this, I've kind of summarized the main ideas because he's pretty wordy in his headlines. It's hard to fit in that little PowerPoint box right up at the top. So build with local, low-energy materials and methods, and design no bigger than needed. So kind of what he's talking about, what Keval is talking about, is build local, build raw, kind of like eat raw, right? And build small. Any of y'all recognize this building? Give you it's local. It's awesome, right? At least if you grew up in small town Texas and you kind of lean towards redneck, right? Yeah. I think it's awesome. I'm with you, man. Okay, so this building is from Reclaim Space. And basically, they're a prefab company that operates out of Austin, Texas. So they've got a team of guys and girls that go around and they find old farms, old barns, old houses, things of that nature, and they go and strip all the wood, all the the old tin roofs and things of that nature off of these barns for next to nothing, except for their transport costs and their obviously their driving costs and things like that. And then they slap it on a steel frame that's prefabricated in their shop, and they ship it out on trailers and drop it on a piece of land. They tie in utilities from there. It's a pretty interesting product. These actually run anywhere from about $125,000, which when you're thinking about a starter home of that general square footage, ain't that bad. Up to, they've got some 500,000 luxury offerings as well. Pretty awesome. So here's something a little more conventional looking, right? This is a home that's out in Belgium. What you see are locally produced bricks, locally produced clay tiles, and then something we're going to talk about later on, a big old glazed window that happens to point to the south. We'll talk about that later on. But the point is, with these two examples, that you can design something kind of unconventional, but it's awesome if you're a redneck, or you can build something that looks pretty conventional, and that would fit in with just about any neighborhood you can find in the world. And you can still do it with local, low-energy materials, like something that's been stripped off of a barn or something like that, or something that's been produced right down the road. So, when he's talking about building local, building raw, and building small, there's a couple things that we need to talk about as well. What's the whole concept of eating raw? Any of you guys into the diet or anything? What you got, Jake?
Well, I mean, food actually has I don't know the exact term, but there's an electrical current in raw food because it's still alive. When you eat it, it's better for your health.
Wow, I've never heard that.
You have to sleep less, higher energy content.
Okay, yeah.
I think
awesome.
To mitigate the overall chemicals coming into your body.
Yeah, absolutely. You don't want a lot of process, like preservatives and things like that, generally speaking. At least that's the philosophy behind it. Y'all have all heard the concept of eating on the edge of the grocery store, right? Go get your produce, go get your meat, go grab a little bit of grain, stay the hell away from the Pop-Tarts and the toaster strudels, right? Just get out of there. It saves money and you end up being a little bit leaner. So it's the same concept. Something interesting that I was researching in the course of this, and actually thanks to Ryan, I heard the term womanized. And so I started looking into womanizing lumber. Everybody's heard of pressure-treated lumber, right? Okay, so we frame the vast majority of all of our buildings with pressure-treated pine, pressure-treated lumber. And why do we pressure-treat it? And what does that mean? Anybody know? What's up?
Increase strength.
Absolutely. Well, yeah, okay, absolutely. And then it also, what's up?
It lasts longer.
It lasts longer. What's it trying to fight? What would degrade it?
Microorganisms?
Absolutely.
Weather and insects.
Weather and insects. There you go. Termites, mold, decay, whatever. So Carl Woolman came up with a process in which you place lumber into a cylinder. They suck all the air out of that cylinder and make a vacuum. And then they introduce, and this is why I have my note sheet, chromated copper arsenate, CCA, into the lumber. They pump it into that chamber. Because there's a vacuum, it permeates into the fibers of the wood. When it comes out on the other side, you've got rot and insect-resistant wood, basically. What we found out was that when guys like Jason Teal are working in the wood shop and they're sanding or cutting that lumber, they're breathing in particulate matter. And chromated copper arsenate is extremely toxic. And so they started seeing health defects and things of that nature. So then we moved on to safer amine copper quat, ACQ, or copper azole. You think those are going to be much better? Jury's still out. We think that they are. Hopefully they are. but there's probably better solutions. One solution is TimberSill. It's still being tested. Some of the architects in the room may have heard of that. Basically, they do the same pressure treating process, but they use silica instead of the chemicals. So it's basically kind of like glass encasing your buildings. Now, they've had some issues in production from what I've seen, but it is a safer method. Eating or building raw is still on its way. We're still working on it. I'm not going to talk about transect theory right now. Some of y'all will remember this slide. I'm trying to get my mileage out of it, just like my Tacoma. But basically, the transect is basically the concept of dividing our world into 6 different sectors, from the most urban to the most natural, and you have areas in between like suburbia, right? And different materials and different technology are appropriate in different transect zones. So, light imprint technology, Thomas Lowe's article, focuses more on stormwater and on also pervious surfaces versus impervious surfaces. And what he does is he lays out a toolkit. For example, this is the paving toolkit. And he's basically showing you concrete is what we talk about with paving most of the time, right? And most subdivision regulations lay out that concrete is what you will use. Come hell or high water, we will have concrete on the roadways, right? What he's trying to show you is that that's not the only option. In fact, there's much more cost-effective options that are appropriate in certain zones. Now, you're not going to put compacted earth on a highway where you got 70 mile per hour speeds and 50,000 cars coming down in a day, right? But does compacted earth and crushed stone and shell make sense if it's a back lane in a rural area that's only going to see one car every week or something like that? Heck yeah, and you can probably get it out of your local quarry or something like that. That's the whole idea between light imprint. It's got tools like these, materials, and it's also got techniques. So he goes over channeling, filtration, and storage techniques. But he applies them through the transect. So you can see, hey, a concrete trough or a sculpted watercourse makes more sense in Manhattan or in Chicago than a natural creek, right? You're going to see that running through the streets of Chicago. But you apply these tools in their appropriate context, and in doing so, you minimize infrastructure costs. The example that he gave, this is the stormwater plan for traditional neighborhood development, which is plan development. This is the infrastructure plan under the light imprint technology. Basically what they did was they used pervious surfaces and they used rain gardens and things like that to naturally filter water on the site. So if this is your pipe and these are your inlet boxes, what's the difference between the two?
A lot of cost.
A lot of cost, which he showed in the conventional engineering. They actually spent more money in the light imprint engineering. They spent more money because in erosion control because they installed tree protection fence. On the conventional side, they didn't even do that. So they came out and spent about $20,000 more over there. But then when it came down to stormwater and paving, there's a couple of things that they did with light imprint. They reduced the streets from 26 feet wide to 24 feet wide. Even though they still use concrete, they took out 2 feet. And so they saved significantly, as you can see, on the paving costs. When they did that, they also took out some sidewalks because they were building rain gardens and things of that nature. So the sidewalk costs started to come down. Because they used less pipe, reinforced concrete pipe, which I wrote down, 36-inch RCPs, about $78 a linear foot right now. 24-inch RCPs, about $24 to $26 a linear foot right now. So every foot of that you take out of the equation, you're saving a lot of money. And they're doing it by digging ditches, essentially. So all in all, on a 42-acre site, which is very attainable for most of us in the near future here, they save 30% per lot on stormwater infrastructure. All in all, on a 42-acre site, that was $500,000. If you can do that for your bosses, you're getting a Christmas bonus. I promise you. So, thank you. That's all I've got.